You did amazing. Thank you so much. I'm going to trip you. There we go. I know. You can just look at these babies for a while. I didn't expect to be queued up so beautifully. That was amazing. I loved your story. I actually not only went to Stanford, but I went to Hopkins. But not the Hopkins Mansion. I did not ever live in the mansion. I went to Hopkins Marine Station. Anyone ever hear of that? I mean, it's pretty... Oh, cool. We should talk. Come and talk to me. For those of you who don't know, Hopkins Marine Station is the obscure second campus of Stanford University that's exclusively for marine biologists. And it's in Monterey Bay, right next to the Monterey Bay Aquarium. Has anyone heard of that? Yeah, I know. It's cool. So I have this pretty heavy, hardcore background in marine biology, and so then I decided to write a book about baby animals, and people who had been hearing me talk for years about squid and octopuses were like, that's new. So I'm going to explain why I went in this direction, and it started actually with my work at Hopkins Marine Station, where I studied baby squid. My whole PhD thesis was actually squid, sex, and babies. And the babies are very cute, just like these babies up here. And because it's my talk, I get to inflict baby pictures on you. This cat is, of course, my own cat. His name is Grasshopper. He's 15 years old now. He's an old man, but this is what he looked like when he was a baby. So I think we can all agree that baby animals are really cute, and there's probably a good enough reason to write a whole book about them. But I have more reasons. And I put these other couple of babies up here because I happen to think they're very cute, but they're a little obscure as well. And so I thought it'd be fun to do a little quiz show. The one on top with its little snoot in the zookeeper's hand, does anybody recognize what kind of baby that is? Any hands? No hands. Nobody's courageous enough for a hand, but I did hear, yes? Yeah, platypus. It's not a platypus, but it's close. It's really close. You guys give him some credit. I'm so sorry. It's another monotreme. It's called an echidna. You've probably heard of echidnas. So echidnas and platypuses are so similar that their babies have the same name. Baby echidnas and platypuses are called, wait for it, puggles. They're called puggles because somebody who studied them saw a plush toy in a store that was branded Puggle, and they said that plush toy looks so much like a baby echidna or platypus that I'm going to steal the name and give it to the baby echidnas and platypuses. That's how cute they are. And one of my favorite things about baby echidnas and platypuses is that the weird group of mammals that they belong to, you may know they lay eggs. They do. There is another weird thing about them. They don't have actual nipples, but because they're mammals, they do make milk. So the way they make their milk is they just sweat it. They just sweat milk. And so the babies just lick it right up, which is why this baby is licking milk out of the hand of the zookeeper, because that's how they do it, which is adorable. Can I get an aw? Yeah, I love you guys. How about the one on the bottom? Does anybody recognize that weird little bird? You guys! It's a heroic audience tonight. That is a California condor chick. And California condors are one of my favorite birds, and I think they're very, very cute when they're babies. Can I get a show of hands? Anybody else think they're cute? Yeah, you're all correct. Does anybody think they're ugly? It's okay, we won't hurt you. It's okay. You know what? A lot of babies are really creepy or a little weird looking. And I'm about to get into some babies that really, really creep most people out. So this whole book is a little bit of a bait and switch. I'm like, come for the kittens, stay for the parasites. But they're important. They're important. This is really the gist of the whole talk, is that babies are important in large part because, believe it or not, most of the animals on Earth are babies. So at any given moment, there are more babies than adults on the planet. And if you think about it, it's because every animal has to reproduce at a greater than replacement rate, because some of those babies are going to die. So these are just classic like eggs in a nest. But if you think about it, almost every bird lays more eggs than there are parents. And a lot of those are going to die sometimes in the egg, sometimes as chicks, sometimes as fledglings. Here's a mammal like us, mama opossum with all of her babies on her back. They're not all going to make it, which is sad. But it's also interesting because it means that most of what's happening in the world of animals is happening to babies. And especially once you get into the ocean. Anybody recognize this animal? It's at the beginning of a Disney movie. Does that help? It's a clownfish, yeah. Remember the clownfish? Remember Marlin looking into the cave with all of the babies and he couldn't figure out what to name all of them and then most of them got eaten. That's what happens. It's so good. I can't watch it, but it's so good. So like a lot of marine animals have thousands of babies, even millions of babies. Here's some squid babies. I'm sorry, they're sort of zoomed out so we don't get to see how cute they are. But this is like a spiral of eggs and like every single tiny little bead on what looks like a necklace around this spiral is a baby squid. So the squid that I studied, the Humboldt squid, they can have up to 1 million babies. So, all right, I'm not going to hammer it home anymore. Most of the animals on Earth are babies. They're really important. They're doing a lot of eating. So if any of you have children, show of hands. If any of you have been a child, show of hands. You may recall how much young humans consume. And nowhere, I think, is this more obvious than in the world of insects. Anybody have a garden? Have you ever been plagued with larvae? That's caterpillars, maggots, borers, grubs. They're all babies, and they eat way more than their parents. A lot of insects don't even eat anything as adults. They only eat as babies. And even the ones that have a rich and varied adult diet are eating massive amounts of food as babies. The top one is a leaf being skeletonized by caterpillars. The bottom one is a tree that was actually killed because of these grubs that bored their way through it and ate everything. So this causes a lot of problems for people, obviously, because we like our trees and we like our gardens and we like our crops that feed us and our babies. And so what I love about this is all of these insect babies that cause problems, one of the best ways to control them is with other insect babies. This is a wasp. It's a mom wasp. It's a grown-up wasp. She's not going to do much except lay an egg inside this caterpillar. I think some of you know where I'm going with this. So we're sort of moving away from the cute babies into the creepy babies now. It can be both, maybe. Inside this caterpillar, that wasp egg is going to hatch, and the baby wasp is going to eat the inside of the caterpillar. This is a picture of what can happen. I know it's a little bit traumatizing, so we'll skip along, but this is a caterpillar full of baby wasps. One baby animal full of other baby animals. It's like baby Mad Max sort of style. Anyway, what happens is the baby wasps make their cocoons. This is a very dead caterpillar, just for the record. Super dead. The most dead. Absolutely, completely dead. Just to make that really clear. And all the wasp babies have made their cocoons and then hatched out of their cocoons to fly away and lay their eggs in other wasps. So I just love this. This is like control of the babies by the babies. Like everything is babies all the way down. So now that I've convinced you that babies are cute and gross and important, I'm just going to run through a handful of other like general baby facts that will bring us to this like deep understanding of just how cool, valuable, and valued baby animals are. And this is sort of connects to the fact that they're abundant. They're also universal. Like literally every animal on Earth starts out as a baby. Just like every single person in this room started out as a baby. It's totally bonkers. Unless anybody's cloned. Any clones? Clones? Any clones? No. This is a bird that has eggs. It's a cool bird called a kakapo in New Zealand. If I had more time, I would talk about them, but I won't. They're just cool. They lay eggs. They can't fly. These over here on the other side are fish eggs. They're little baby snailfish growing up in those eggs. At the bottom, those weird blue capsules are snail eggs that I just spotted in a tide pool one day. And so the world is full of eggs and it's full of babies, and all animals start out as babies. So when you think about it, the future of everything on Earth, all of the animal life, is in these eggs and these babies. There is an exception, which I sort of more than alluded to, just like straight up explained, that there can be cloning. And in fact, that is really common in babies. So the most common place to encounter clones in the natural world is in embryos. Embryos clone a lot. That's in fact where identical twins come from, is from an embryo just naturally cloning in the womb. There are animals like armadillos where every single embryo clones into 4, and so every armadillo gives birth to 4 identical clone babies. It's creepy if you call them clones, it's sort of cute if you call them quadruplets. It's basically the same thing. And that is what is happening in a lot of these wasp babies inside the caterpillars. The wasp embryos clone, and a single caterpillar can actually hold thousands of cloned wasp embryos, some of which are specialized to fight off other wasp embryos, to be all territorial, like, no, this is our caterpillar and we own it and we're going to eat all of its internal organs ourselves because we're very hungry. And then the rest of them are the ones that make these cool little cocoons and emerge. But lots of other animals clone. Anybody ever been to a tide pool like this one and seen some anemones? Yeah. And many of you may already know that if you see a tide pool like this, most of those anemones are clones. Because anemones are really good at just splitting in 2. And then you have 2 anemones. And then pretty soon you have 4 anemones. But what I think is really cool is even animals that clone as adults always make eggs. There's basically no animal on the planet that never makes eggs. And even anemones will make eggs, make embryos, have baby anemones grow up. And this is a picture I really love of a mom anemone she's kind of pulled all of her tentacles in. That's the circle in the middle. And the little circles all around with their tentacles are her baby anemones. She's actually brooding them, keeping them safe. So even the clones, they still start as eggs, they still start as babies, even if there's some cloning and funny business going on there, which brings me to my next topic about babies, which is that babies all get care from their parents. Just like this heartwarming story of the caecilian. So I talked a little bit about milk and a little bit about how mammals make milk, and then there's the weird echidnas that sort of sweat the milk out of their pores. But milk actually goes beyond mammals, and there's a lot of animals that make food for their babies out of their bodies. It's called matratrophy or patratrophy, whether the mother's doing the feeding or the father's doing the feeding. And caecilians, which are these weird little things that look a bit like earthworms but are actually amphibians, like frogs and newts, they make milk skin. The moms actually grow an extra thick skin after giving birth, and the babies, as you can see, I don't even know why I'm talking about this. The whole thing's right there. That's what happens. It's not exaggerated. The babies eat their mom's skin, and then she grows a new one. I have children. I don't know why I'm bringing that up. It's completely irrelevant. I still have all my skin. It's fine. It's fine. So the other picture on this slide is some real worms. These are actually proper worm eggs, marine worms. And each capsule is 4 capsules. Each capsule is packed with eggs. But here's the cue about how they're getting so much care from their parents. Even though mom worm and dad worm don't stick around to feed their babies in person, they've put a huge amount of effort into feeding their babies in the future. So each capsule has only 1 or 2 actual baby worms. Those are the sort of slightly greenish, black spotted blorps in there. Blorp is a technical term, like puggle. And all of the orange spheres are eggs that will never hatch, that were laid in there purely to feed the ones that do hatch. That's it. And so it's a huge amount of effort to lay that many eggs, and most of them are just going to get eaten by your babies. They're there for food. And so I think this is just a really neat thing to notice, that it's not just mammals, it's not just vertebrates, it's literally every parent on the planet is putting a huge amount of effort into taking care of their babies. It's what a huge amount of energy goes into, of effort, of evolutionary process, which brings us to the exception that may come up in your mind if you're thinking about this. Are there any parents that shirk their duties? And in fact, there are. This is a photo of two babies of completely different species. The one on the right is a pin-tailed whita, and the one on the left is a cuckoo finch. It's not a true cuckoo like the European cuckoos that the cuckoo clocks are based off that make the sound cuckoo, but it has the same behavior, and the word cuckoo actually is used to describe this kind of behavior in all kinds of animals where the parents lay their eggs in somebody else's nest and leave it to that parent to take care of the babies. So it happens in birds. It actually even happens in insects because everything happens in insects. I am not even kidding. There are insects that make milk. Ask me about cockroaches sometime, but I'm getting off topic. This is not a cockroach. It's a baby butterfly being fed by an ant because it's a cuckoo butterfly. The babies of these butterflies have evolved to smell exactly like baby ants. And when the ants are walking around outside of their nest, they smell this baby, and they're like, oh my God, it's a baby. And they pick it up, and they take it back to their nest, and they feed it just like their own babies. So I feel like this behavior actually drives home just how much work it is taking care of babies. That like every group of animals around the planet has evolved some way of getting out of it. It's normal. So there's that. But at the same time, this is a huge amount of effort too, because cuckoo bird mothers have to lay their eggs super fast. They have to put a lot of effort into making either their eggs or their babies look convincing. And the babies have to put a lot of effort in too. So it's all really down to this baby butterfly, for example, the butterfly caterpillar, to create the pheromones that make it feel like baby ant, to behave like a baby ant, to not give the game away. Which brings us to one of my last points, which is that babies are super competent. Babies are really, really good at what they do. And this is really one of the things that was driven home to me by researching this book, is that no baby is just an incomplete adult. No baby is just a stepping stone on the way to being an adult. Every single baby is exquisitely adapted to its own environment and its own needs, which are often really different from the adults. So these two pictures, I did get a baby squid in there. You'll see that's on the bottom, but does it look like a squid? Barely. And the one on the top is a baby tuna. They're both tiny, tiny, tiny compared to their adults. And so they have adapted to a totally different type of life. They're transparent so that it's hard for predators to see them. I mean, anyone ever seen a transparent tuna? Who said that?
Liar.
No, I believe you've all seen one right here on the, so, you know. And they swim in a different way because when you're that small, swimming in ocean water is like swimming in honey. So they've evolved like a different body shape. These little squids swim more like jellyfish than like an adult squid. They're like just perfect at being what they are for the time that they are that thing. They're good at protecting themselves from predators. They're good at eating. And they're really good at creeping us out, too. So this is another insect. It's always the insects. This is a caterpillar. Now, caterpillars, like insects and other arthropods, molt. That means that when they get bigger, they have this hard outside skin, and they have to break it open and climb out of it to grow a new skin. So that's molting. That's what they do. And most caterpillars, when they molt, they just leave their old skin behind, or maybe they eat it to get it out of the way. This caterpillar, when it molts, it keeps its old head. And it stacks its old head on top of its new head. And it does that every single time. And so it's called the Mad Hatterpillar. I didn't make it up. I wish I made it up. And honestly, I would not eat that. So that scares all the predators away. And this baby is fine. It doesn't need mom and dad around to protect it because it can protect itself. It's doing great. So you might be thinking, again, any of you who are parents or remember being a baby yourself, that there is an exception to the competent baby rule, and that is, of course, humans. Again, I'm inflicting baby pictures on you. These guys are mine. Thank you. I know they look weird, but it's really sweet that I'll tell them you said, I won't tell them I said they looked weird. But they're really bad at surviving, actually. But you'd think that. But they're really good at getting adults to take care of them. They have tons and tons of specialized adaptations to being a baby human that are different from being a human adult. On the top, my daughter is demonstrating the startle reflex. And babies are full of wacky reflexes that help their muscles develop, that help their parents take care of them, that help them get what they need from their environment. On the bottom, there's my son crawling in the dirt. It's perfect. Crawling, just like the baby squid and the tuna, it's a different way of moving because the body isn't set up to walk yet. And so they have this whole new way of moving that gets them where they need to go, keeps them really close to the dirt and the nutrients that they need to ingest. It's true, to get their guts going to digest things in the future. Even baby kangaroos, this is a weird little kangaroo, Joey. It looks like an embryo, but even this thing is specially adapted to do what it needs to do, which is to crawl into the pouch. So baby kangaroos are like super buff by comparison to other babies, and strong enough to crawl into the pouch all by themselves. And that's where they latch onto a nipple, and the baby kangaroo and the mother kangaroo enter into this dialogue, and the rest of that baby kangaroo's development is an interaction. It's not determined by the parent. It's determined by what the baby needs and what the environment can offer. And that lasts all the way through. Our last little moral of the story here. It lasts us all the way through to the baby growing up. So here we can see the baby kangaroo still getting a little bit of what it needs from its mother's pouch. The milk inside that pouch has changed dramatically from when it was that tiny little buff embryo. It's a totally different mix of nutrients and chemicals, and it's more of what this baby needs to supplement the other food that it's no doubt getting in its life. So growing up is gradual in some species like kangaroos and humans, and it's quite sudden in other species like cicadas. So this is my other picture here. This is a cicada molting. That's the reason I told you about molting, and it wasn't just for the creepy Mad Caterpillar. This is an adult cicada emerging from its nymph skin, its baby skin. And it happens all of a sudden. It's been busy growing wings under its skin, which, like, if you've ever felt like you needed to crawl out of your skin, you could be a cicada and you could actually do it. I went to see the cicada emergence in spring of 2020, like right after I got vaccinated, and it definitely resonated with me. I was like, I'm gonna crawl out of my skin, and these guys are doing it. I love it. After all these months of quarantine, it was great. So the cicada emerges as an adult, all in a flash, all in one moment. It grows up and it is ready to mate. This is an example of one that like barely eats as an adult. It did all of its eating for 13 or 17 years underground, and now its sole purpose in life is to get it on and lay those eggs. However, there are animals that do very little growing up, and these are probably recognized by most of you. Does anyone know what this is? Axolotl. Axolotls are so awesome. They're amphibians, like the caecilians we met earlier, who grow the creepy milk skin. And the classic amphibian life cycle, if you think of a frog, is that it lives in the water as a baby, and it has gills and a tail, and then it emerges as an adult and loses the gills, breathes air, gets legs, jumps around. And axolotls say, no thanks. We are going to make like Peter Pan and stay young forever. And their gonads mature so that they can reproduce while they keep their gills and live in the water. There's a mammal that does something similar. Does anybody recognize this? It's a naked mole rat. They kind of look like old people, but they also kind of look like embryos. And honestly, like if you have ever looked at a newborn human, you understand the similarity. They're all wrinkled and old. So the naked mole rat has many similarities to the axolotl. It has a lot of embryonic features that it keeps its whole life. And along with that, it's completely resistant to most age-related health problems. And so these animals are sort of, to me, a great example of why understanding babies and development is so important. Because it's important for the world that's full of babies, that most of the animals are babies and most of the eating is being done by babies. But it's also, from a self-interested point of view, really important for us to understand our own bodies and how we develop through our lifetimes. And a lot of the research on these sorts of animals that seem to have discovered a fountain of youth is being used to understand how aging happens in humans, how we can combat age-related degeneration and disease, and is just like so interesting besides having cool medical applications. So I think I am out of time. So I will close with that final thought and just say thank you all so much for listening to me. I'm going to jump ahead. Ignore these slides.
Ignore those slides.
And if you want to find me online, these are the places to go. If you want to find me here after my talk, I'll be at a table in the back with copies of these books. Thank you again.
All right. We have time for one or two questions. I'm sure that there are questions about babies. Oh, I see a very enthusiastic hand back there.
So you talked about the neoteny of humans, right? Well, with ants and other colonial animals, they're dependent upon the babies to survive. Like, have you researched the spectrum between the two?
Right. Well, so this is a great point. The question was about